In this video, we're going to talk about how to determine whether a matrix product is defined. For the product of two matrices to be defined, the number of columns in the first matrix must be equal to the number of rows in the second matrix. In other words, our A matrix must be an m by n matrix, while our B matrix must be an n times P matrix. The number of columns in the first matrix must be equal to the number of rows in the second matrix. Let's consider the following matrices. Suppose I have matrix A, which is a 3 by 2 matrix whose entries are 1, 4, 2, 3, 5, 2. Suppose I have matrix B, which is a 2 by 2 matrix, and the entries are 2, negative 1, negative 1, 8. I'd like to find the matrix product A times B. So I begin multiplying the rows in A by the columns in B. So I have 1 times 2 plus 4 times negative 1 then I have 1, negative 1 plus 4 times 8 going to the row 2, column 1, I have 2 times 2 plus 3 times negative 1. Now row 2 and column 2, I have 2 times 3 I have 2 times 2 plus 3 times negative 1 Whoops. Okay, so that was our first. We had row 2 times column 1, and now we're multiplying row 2 by column 2. So that gives us 2 times negative 1 plus 3 times 8. Now we're moving on to row 3, column 1. So I have 5 times 2 plus 2 times negative 1. Now row 3, column 2. 5 times negative 1 plus 2 times 8. This gives us 2 minus 4, so that's negative 2. Here we have 4 minus 3, so that's 1. Then we have 10 minus 2, which is 8. Here we have negative 1 plus 32, so that's 31. Then we have negative 2 plus 24, that gives us 22. Finally, we have negative 5 plus 16, which gives us 11, our matrix product. Next, I'd like to use the same two matrices And this time, I'd like to find the product b times a. So that means we have 2 times negative 1, 2, negative 1, negative 1, 8 for our entries in matrix B, multiplied by the entries in matrix A, which are 1, 4, 2, 3, and 5, 2. So let's begin our multiplication. We have row 1, column 1 to start. So that gives us 2 times 1 plus negative 1 times 2 plus, and now we run into a problem because we only have 2 entries in row 1 of matrix B, but we have 3 entries in column 1 of matrix A. So see here we had 2 times 1 plus negative 1 times 2, but now we have nothing in matrix B to multiply by 5. Therefore, B times A is not defined. And this brings us to an important point when we're working with matrices. Unlike multiplication when we're doing general arithmetic or basic algebra, matrix multiplication is not commutative. In other words, matrix A times B does not always equal matrix B times A. In many cases, you'll find that you can obtain a product for AB and BA, but there are also many cases where you will not be able to, just like in our last example. In fact, I'd like to amend this last statement. Matrix AB does not always equal matrix BA, where we have the product of matrices A and B, or B and A. In fact, matrices A times B will rarely equal B times A, even if both matrices are defined. With matrix multiplication, we're not able to switch around the order of our factors and get the same result as we would in arithmetic. Anyway, this concludes our example. I hope you found it helpful, and see you next time.